Okay, so this lesson is over section 3.3, which covers intercepts. Okay, there's two different types of intercepts. We have the x-intercept, graph crosses the x-axis. So here's my x-axis, this is my y-axis. So my x-intercept, just the point where it crosses the x. So for instance here is 2, the y value is 0, so my x-intercept is 2, 0. Y-intercept is where it crosses the which is the vertical axis. So say you just trace your ground until you find where it actually is the y-axis. Okay, happens down x is y is negative 8. Okay, so x is 2 when y is 0, and when x is 0, y is negative 8. So that's your x and y intercepts. That's kind of, notice that for the x-intercept, the value of y is always 0, and for the y-intercept, the value of x is always 0. Okay, that's going to come into play when we start looking for our intercepts here in a little bit. Alright, so if they want us to just find the x and y intercepts, very easy, you just have to find them. Now, it is important as ordered. Okay, lazy a lot of times, and we just write the intercept is, 5 or whatever it is. Point. An intercept is a point. Okay, so if I want to find my x-intercept, go to my x-axis here, I trace my graph to the x-axis, and I just write the point, okay, the coordinates for that point. So x is 1, 2, 3, 5, so this is 5 when y is 0. Okay, and y is 0 because it hasn't gone up or down the or on the x-axis, sorry. Do the same thing for the y-intercept. Okay, so for the y-intercept, the y-axis, same sort of thing. You trace your graph here until it crosses the actual y-intercept. Okay, the y-axis, that's your y-intercept, which ends at when x is 0, and we know because we haven't gone left or right. Okay, when x is 0, y is 1, 2, 3, negative 3, right? Because down, up. With your x-axis, negative is left and positive is right. Okay, so that would be my intercepts. Now, there can't be more than 2 linear, so there's only going to be 2. Okay, but if I have a deck or something, I would have multiple intercepts. Okay, so you would list them all. So here, I'm looking at the x-intercepts, so I'm going to list all of them. The first one, again, you just follow where it acts the axis. So right here is one of them, which happens at 1, 2, 4. So that's when x is negative 4, y is 0. Okay, but I also have another one, so my graph comes back across again. So here I have x is 2 when y is 0. So I have 2 x-intercepts here, which is acceptable. Okay, we also have to do our y-intercept, which is just where it crosses the y, which happens here at 1, 3, 4. So at y is equal to 4, 0, 4, okay, that's going to be our y-intercept. X is 0, we haven't moved left or right, we just 4, that's where we find our y-intercept. Okay, so same sort of thing on this last one. We have a circle, so we've got multiple intercepts. Okay, so you're just going to the same rules. Take your x-intercepts, or your x-axis where it crosses, those are going to be your x-intercepts. So my x-intercepts, okay, the first one happens right here, which is at 1, 2, 3, so that's negative 3, 0. And the second one happens right over here, which is at 1, 2, 3, 0. So I had one at negative 3 and one at positive 3. Same for the y. Okay, I've got one up positive 3, but it's going to be 0, 3, because here x is 0, my y is 3. And then the bottom one, my x is automatically 0, and then y is going to be negative 3. Okay, so there's steps there. We've got all 4 of them listed out, 2 x-intercepts, 2 y-intercepts. Okay, now here's something like this. Okay, directly through what we call the origin. Okay, the very graphs where x and y axis meet is called the origin. X-intercept and my y-intercept are going to look the same. Okay, my x-intercept go through, it is 0, 0. X is 0, y 0. Okay, because I haven't moved left or right, I haven't moved up or down, I'm exactly in the middle. Okay, same thing with your y-intercept, it's also going to be 0. Okay, because it crosses the y-axis at the 0 point. So they're both going to be 0, 0 there. That's perfectly fine. That happens. Okay, and now here we have vertical line. Okay, now the vertical line is the one that kind of confuses people, the vertical and horizontal lines. Okay, so when I'm looking for my no problem, same sort of thing. Okay, I go to where it crosses the axis. So here's my x-axis. So 2, 3, 4. Negative 4, 0 crosses the x-axis. And then the y-intercept, don't make this harder than it needs to be. The y-intercept is where it crosses the y-axis. Well, this is a vertical line, which runs parallel to the axis, so they're never going to actually run into each other, so they're in. Okay? Just write that. You write none. Okay? So that's basically what finding the intercepts when you're given a graph looks like. Really compare. So then find the intercept by solving. Okay, now this is a little bit more difficult, not too difficult though. So if I want to find the x-intercept equals 0 and solve for x. Okay, because if you look at our values for x-intercepts, my y value is all 0. Okay, the y value there is always 0. If I want to intercept, you just set 0 if I'm looking at an equation. Okay, to find the y-intercept, you set the x equal to 0. Okay, so if I want, we make x equal to 0, which should make sense. I can't find the x by setting the x equal to this would go away, right? So we need to do the opposite. To find x, we let y 0. To find the y-intercept, you let the x equal 0. Okay, so here we go. We're going to find both. Now, on your test, you will have this way, okay? It's going to say specifically, find using x-intercepts must show work. Okay, so plan on just graphing things and then trying to find the dots. We're going to teach us later on. So make sure you know how to actually process, not just use your calculator. Okay? So here, I want to graph x minus 3 by finding intercept. So they need me to find and plot intercepts. So find our intercepts. So it says to find the x-intercepts, okay, we want to make y equals 0. Okay, so we're going to do exactly that. I'm going to take my equation. I'm going to plug a 0 in for y. So minus 3y, so instead I'm going to put the in, is equal to 6. Okay, so now I'm just going to solve. 3 times 0 is 0. Just goes away. X is equal to 6. Okay, so my x-intercept is 6. Okay, so now we come over here to our graph. And on x-axis, you're going to go over to 1, 3, 4, 5. I think I got that. Get a little cross-eyed looking at these. Okay, so I've got a point here at equal to 6. Y is equal to 0. So we're right axis. We haven't gone up or down. So that's only one graph with one because you don't know which to go. I could do all kinds of directions from there. So we have to have at least two lines. So we're going to find our other intercept. Okay, so now y-intercept, and I do that by plugging in a for x. Okay, so it's 0 for x. So here we go. So instead of x, I'm going to put 0 minus 3y equals 6. Okay, 0 just goes away. I have 3y equals 6, negative 3. And I've got equal to negative 2. So the point here is when x 0, because we made x 0, y is negative 2. Okay, 0, y is negative 2. So there's my coordinate point. Okay, so here we go. When x is 0, that's right here on the y, negative 2. So we go down 2 units. Now I've got 2 points, which I then just need to draw the actual graph. So we're going to connect. I'm going to use my ID here. Well, you should have your ID. Easy. Okay, so then you just, your line, the 2 dots, arrow sides, because the graph continues on forever in both directions. And so that graph using your okay, find your 2 intercepts, plot your 2 intercepts, draw lines your 2 intercepts. Okay, you continue it on in both directions. Sorry, I moved it out of the way. Make sure you continue on in both directions. You don't want to just connect the 2 dots. That would imply it and go past those dots, but it does. So now we're going to do more of the graph. X is equal to negative 2y by finding and plotting intercepts. Okay, so finding and plotting intercepts. So x-intercept plug in equals 0. So equal to negative 2 times 0 equal to 0. Okay, 2 times 0. So it's 0, 0 for my x-intercept, which should already tell you your y-intercept. I'm going to prove it here. When I plug x0 in, okay, we're going to do the same thing. So it's equal to negative 2y. Divide by negative 2. 0 over negative 2 is just so I get y is equal to 0, and x is 0, y is 0. Which we should have already seen from here. Goes through 0, 0. Well, my intercept has to go through both 0, 0, both of them. Now this column, we can graph the I end with a dot in the center. Okay, and I mentioned the fact that you have to have 2 dots in order to create a graph. Not create a graph with 1 dot, because who knows which way it goes. Up, it could go down, it could go all kinds of directions. Okay, you make it up, need another. Anytime your x and y intercepts are exactly this, as far as they're 0, you're going to pick another point and plug it in so that you can get a second point. Now it doesn't really matter which point you use. Okay, any will do. Okay, any point will do. So let's make a little note to ourselves. Pick another point. If graph goes through 0, 0. Okay, so we're going to have to pick another point if the graph goes through 0. Okay, so here we go. Here's our third point, really, okay, because 2 of them are the same. So let's make x equal to, now here you want to pick. Okay, if I make x equal to 1, then I'm going to have -2, and I'm going to get, and we don't really like fractions. So I'm going to make x equal to 2 so that it matches up nicely. So I'm going to plug in the and for y. Okay, so I'm going by negative, so that means y is equal to -1. Okay, it's not -1, which is what a lot of people like to do, but this is 0, 0 because I put 0 and 0. Plugged in. So my point 2, -1. When x was 2, y was -1. Okay, when I plugged in x, I got a -1. I don't graph it on this anymore. I have to graph point right here. So I'm going to come over here where x is 2, so we count right. Y is -1. We go down 1. There's my second point. Okay, and it doesn't matter which you chose, because you get the exact same line. So let me turn this so I can draw a line, try to make it somewhat accurate. Okay, so there's my arrow. There's my line. I drew my arrows. It went the origin point that I... Now, it didn't matter which x value I chose. So if I would have chosen a different x value, okay, for instance, if I would have chosen 4, 1, 2, 3, -2. Okay, so 4, y is 2. No matter what x value I chose, even if I chose 1, y would -1/2, sorry. Y would be 1/2. You see that it goes... Now, I'm trying to be as accurate as possible, but it's kind of hard to be perfect when you small graph. X value I would have landed somewhere on this line, so my line being the exact same line no matter what. Okay? Alright, so that's how you deal with you get a point in the origin. Okay, so let's try another one. So graph 4x equals 3y minus 9 by finding and plotting intercepts. Okay, so here we go. Finding and plotting intercepts should be easy. X-intercept, plug in a y equals 0. Okay, so we're going to use this equation right here, and we're going to plug in a 0 for y. So I've got 4x is equal to 3 times 0 minus 9. Okay, so 4x is equal to 9 divided by 4. Just basic for x. Okay, we've already done that. We did 2. Okay, so equal to -9/4. Okay, -9/4. So with that, I can't really deal with, and how do I graph that? Well, first of all, find an approximate or an equals or an exact decimal value for it. This is going to be the one time where I say that decimal here to work with in fractions. Okay, because we can't really, it's hard to graph a -9/4. But if I change the value, -9/4, -0.5. Okay, now -2.2 from graph. Okay, so when I get my y-intercept, so when x-intercept, so when y is equal to 0, that's on this x-axis, x is -2.2. Okay, so here we go. 1, 2. Now, to get the 0.25, you're just going to go a little past and draw your dot. Okay, because let's be honest, by my dot, it almost takes up the entire thing anyway. Exact is a little difficult. You just want to be close. Okay, show a little more -2, but it's not all the way to the 3. It's not to the half part. Okay, so that's kind of what I'm looking for when you graph that little point. Okay, show that it's a little more than -2, and that should be good enough. So now we've got to find the y-intercept by plugging in x in for 0, 0 in for x, times 0, 3y minus 0 is equal to 3y minus 9. Variables the ones to the other, just like we did last, so plus here, so I get 9 is equal to 3y, divide by 3, and I get y is equal to 3. Okay, so y is 3, so here's my ordered pair. Oh, for this one I forgot to write my ordered pair, -2, 5, comma 0. Okay, and for this, when x is 0, y is +3. So when 0, y is +3. That's up here. Draw your line. Okay, try to be as accurate as possible. Arrows on both ends because it can forever on both directions. Okay, so all that. Okay, I would suggest that you go back, if you're having a hard time with this, go back through and try to redo this one on your own, the same exact answers. So now the next one is a little bit different. Okay, x2 by plotting okay, x-intercept. So if I want to do the x-intercept, it says to n a y equals 0. Okay, well, small little there is that I don't replace the plug in a y equals 0. If I make y 0, well, it's x is equal to 2. It's already solved for me. Okay, so 0 is 2 automatically. So the point here is that when x is y is, or when y is 0, x is, okay, when y is 0, 2. You can, because there's nowhere to plug it in, so x2 when y is 0. That's how that looks. Y, on the other hand, x equals 0. Well, now when I do that, I get 0 equals, okay, 0 does not equal 2. Okay, this does work. Okay, this does not work, so there is no y-intercept in for that. As soon as I can finish spelling, or at least spell at the same time. Oh, you can't really see that. Okay, so this does not, 0 does not 2, so that does not work. There is no y-intercept. Why there is intercept is because x equals 2 is a vertical line. So we draw our point, x equals 2, so 1, 2, there's my x-intercept. And there is no y-intercept, so do not have an intercept to have a perfect vertical line that runs parallel with this so that it never, ever, ever crosses it. Back from geometry, the definition of a parallel line is that they're never, ever, ever cross. Okay? So that's what that looks like. It's a perfectly straight up and down line when you have x equals 2. So it's right here, there's vertical lines. The graph you'll see where C is a real number is a vertical line with x-intercept at C0. So that's just big fancy way. Whatever this number is, that's going to be intercept and vertical line. When x is 2, 2, 0 is my x-intercept, and it's a vertical line. Okay? So now we've got one more here. Okay? Graph y equals -3 by finding and plotting intercepts. So same, here we go. X-intercept, we're going to plug in a y equals 0. So when I do that, here I get 0 equals -3. Not true. Okay? So since this is not true, that means there is no x-intercept. Okay? And if you're watching vocabulary, you figured out kind of where we're going. So I have no x-intercept this time, but what happens when I do the y-intercept? X equals 0. Okay, well, x equals 0, y still is 3, so my point here would be 0, -3. That's my y-intercept. Okay, so when x is 0, y is negative. Okay, so the only way to not have an x-intercept is parallel to that axis. So you don't have an intercept parallel to the x-axis. That's the only way to not cross is to be with it. Okay, so it's going to continue on and on forever, both to the left and right. Okay, so the number is vertical, which is backwards, but imagine x means there's an intercept, and then y equals means there's a y-intercept, x-intercept to be parallel to that axis. Okay, so then here's your down here, the y equals, where C is a horizontal line with step 0c. So same sort of thing, y equals some number, okay, means there's a horizontal line with a y-intercept at that number. Okay, pretty simple. A little bit of information to kind of intake all at once, but if you go back through it, you can watch this video as many times as you want to and get a hang of the intercepts. Good luck.